Hello there, Mr. Sutton here, bringing you the AB Calculus 514 homework solutions on integration by substitution in indefinite integrals. For this problem, we're trying to take the antiderivative of this function in here. Now, I see in here that I've got a function like 4 minus x squared and its derivative in the same problem in kind of a product relationship. So this is probably a good candidate for substitution. I'm going to let my u value be 4 minus x squared, because I know that if I take the derivative of 4 minus x squared, I'm going to get something with an x, which I can then cancel this x over here out with. So I'm thinking ahead here. Derivative of this is going to be du equals negative 2x dx, and then isolating dx, we have du over negative 2x. All right, time to do some substitution. So back in the original here, I'm going to write square root of u, and then I'm going to have, instead of dx, I'm going to have du over negative 2x. So these x's are going to cancel out. And if I simplify things a little bit and rewrite this with an exponent, I've got negative 1/2 u to the 1/2 power. And at this point, I'm just going to use my reverse power rule to take the antiderivative with respect to u. So this bumps up to a 3/2, and we're multiplying by 2/3. Negative 1/2 times 2/3 is going to be, let's see here, negative 1/3. So we've got negative 1/3 u to the 3/2 plus c. But all the answer choices are in terms of x, so that means I have to substitute back in for u. So now I'm going to write negative 1/3 times 4 minus x squared quantity to the 3/2 plus c. And if I want to, I can make this all one big fraction over 3, just to make it look like one of the answer choices. So that's going to be answer choice E. So on this problem, it seems kind of easy because they want you to use substitution clearly, and they're already telling you what to let your u value be. It's going to be x plus 1. So let's just start doing that and see what we can turn this integral into. So if u equals x plus 1, we take the derivative of that. So that's going to be du equals, well, this is just going to be 1 dx. So then substituting back in, I can rewrite this as x over the square root of u times du. And that's great, except there's one problem. It doesn't match any of the answer choices, and this x up here is not getting canceled out by anything. So what can we do in situations like this when we're not canceling out the x? Well, we're going to use this equation that we have here, u equals x plus 1, a little bit differently than we normally use it with substitution. So in order to really satisfy this problem, I need to replace this x with something that has u's in it. So over here, I see u equals x plus 1. If I isolate the x to get that by itself, I can rewrite this as x equals u minus 1. And the nice thing about this is wherever I see an x in the original, I can now substitute u minus 1 for x. So up here, this is just u minus 1. And does that match any of the answer choices? Not just yet. So we have to do a little bit more work here. We can actually simplify this a little bit. This is really u minus 1 divided by u to the 1/2. So we could actually divide each of these individually by u to the 1/2. U divided by u to the 1/2 would be just u to the 1/2. We're just doing 1 minus 1/2 for the exponents. 1 over u to the 1/2 would be, this would be minus u to the negative 1/2. So we just divided both of these by u to the 1/2. And that finally matches answer choice C. For this problem, we're trying to find the indefinite integral for this crazy expression in here. Since there isn't really a good way to simplify this otherwise, and I noticed that I've got like an x to the 1/3 and a 2/3, I'm thinking maybe I might be able to use substitution on this. Let's try letting u equal this x to the 1/3 minus 4. And then if I take the derivative of that, we've got du equaling 1/3 x to the negative 2/3 dx. And then if I just isolate the dx, I can multiply both sides by 3. And if I divide by x to the negative 2/3, well, that actually ends up moving this x to the 2/3 into the numerator. So we've got 3x to the 2/3 du is equivalent to dx. Doing my substitution back in the original now, This stuff in the beginning, I can call this u to the 5th over 6x to the 2/3. And instead of dx, now I'm going to swap that out for 3x to the 2/3 du. Now, conveniently, the x to the 2/3 are going to cancel out, and we'll have a 2 down here. So we can call this 1/2 u to the 5th du. And now if I take that antiderivative, bump that up to a 6, divide by 6, so we're going to have u over 12, or u to the 6th over 12 plus c. And then as a last step, we're just going to swap the 1/3 x, well actually no, x to the 1/3 minus 4 back in for u. So like so. And then let's see if that matches an answer choice. Looks like that's answer choice A. For number 4, I'm trying to find the indefinite integral of 3x squared over square root of x cubed plus 1. So for this one, since I noticed that I've got an x cubed and an x squared in the same problem, basically a function and its derivative, I'm going to try integration by substitution. Let's let u equal x cubed plus 1. I don't want to mess with the square root. Let's just deal with the x cubed. Du is going to be then 3x squared dx. And I know I'm going to have to substitute back in for dx, so I'm going to divide by 3x squared to get dx by itself. Now it's time to substitute. I'll rewrite this as 3x squared over the square root of u times du over 3x squared. Conveniently, the 3x squareds here cancel out completely, so I have just 1 over the square root of u. Now I'm going to rewrite that as u to the negative 1/2 just to make my next step a little easier. Using my reverse power rule, I'm going to bump that up to a 1/2 exponent, and then dividing by 1/2 or multiplying by 2, I've got 2 times u to the 1/2 power. I will now substitute x cubed plus 1 back in for u, and I do have a plus c here, by the way. There we go. Can't forget that constant of integration, right? So then I've got 2 times, and this 1/2 power is really square root of x cubed plus 1, all of that plus c, which gives us answer choice A. For number 5, I'm trying to take the integral of x over x squared minus 4. Now on this one, since I have a function and its derivative, or something that's close to its derivative, in the same integrand, I'm going to try integration by substitution before any other techniques. So let's see, u equals x squared minus 4. I mean, we could try partial fractions on this, but integration by substitution is a lot less work if it works. Derivative of this is going to be du equals 2x dx. And then I have to get dx alone so that I can replace it back in the original here. So I've got du over 2x equals dx. Substituting back in now, this is going to be x over u times du over 2x. These x's cancel, which is great, so I still have a 1/2, and now I also have a u to the negative 1 power. Now I know that the integral, the antiderivative of 1 over u, or u to the negative 1, is just ln of absolute value of u. So this is 1/2 ln of absolute value of u plus c. None of my answer choices have u's in them. They all have x's. So I'm going to have to replace this u with x squared minus 4, which I will do now. And let's see if I have any of those answer choices. So it looks like answer choice C is a match. Let's go with that one. For number 6, I'm trying to take the integral of x squared times cosine of x cubed. Since I have an inner function whose derivative is elsewhere in the problem, I'm thinking integration by substitution is a good shot on this one. So let's let u equal x cubed, and let's try this out. Du then would be 3x squared, and then dividing by 3x squared, I've got du over 3x squared equaling dx. Let me substitute back in now. I'll rewrite this as x cubed times cosine of u times du over 3x squared. The x squareds cancel. I still have a 1/3 here times the cosine of u. And now I'm going to use my antiderivative rules. Antiderivative of cosine is sine, so this is 1/3 sine of u plus c. And since none of my answer choices have u's in them, I'm going to replace this u with this x cubed. So I've got 1/3 sine of x cubed plus c. And then looking at my answer choices, it looks like answer choice B has what I'm looking for, so we're done. For number 7, I'm trying to take the integral of x squared over e to the x cubed. That's a crazy denominator there. I do notice that this inner function of x cubed has a derivative of x squared that's in the integrand also. It's not the exact derivative, but it's pretty close. So I'm going to try using integration by substitution here. So I'll let u equal x cubed. So then du is going to be 3x squared. And then dividing, we've got dx equals du over 3x squared. Let's do some substituting now. So I can write this as x squared over e to the u times du over 3x squared. Canceling out my x squareds, I can rewrite this as 1/3 times e to the negative u. I'm going to bring this upstairs here. And then taking the antiderivative, this is going to be negative 1/3 e to the negative u. But none of the answer choices have u's in them. So I'm going to replace that with x cubed. So this is then negative 1/3 e to the negative x cubed plus c. And do I have an answer choice that has that in there? Well, pretty close. I need something negative. The only negative options are a, b, and c. And it looks like c, they've moved the e to the x cubed downstairs. So let's go with choice c then, because I can do that with my exponent rules. For number 8, I'm trying to take the indefinite integral of x times e to the x squared. So for this one, I notice right away that I've got an inner function of x squared and its derivative, or something close enough, this x, in the same integrand. So I'm going to try u substitution on this one. So I'm going to let u equal x squared on this. So then du is 2x dx. And dividing by that, I've got du over 2x equals dx. Substituting back in, I can write this as x times e to the u times du over 2x. I can cancel the x's here, so that's just going to be 1/2 times e to the u. And that's a pretty easy antiderivative. That's just 1/2 e to the u plus c. Don't forget your constant of integration here. But none of the answer choices have u in them, so I'm going to substitute x squared back in. This will be 1/2 e to the x squared plus c, which is going to give me answer choice A. On this problem, I'm given that the derivative of y with respect to x is sine of x cosine squared of x, and I'm told that when x equals pi over 2, y equals 0. Based off of that, I want the value of y when x equals 0. Okay, so this is the kind of problem you would typically see in an introductory differential equations chapter, but we actually do have enough right now at this point in the year to figure this one out. So I'm going to use the fundamental theorem of calculus. I know that since I have a derivative here and an initial value, I can use that to find any other value of y that I want. So I'm going to write f of 0, because that's what I'm looking for essentially, equals f of pi over 2 plus the integral of this derivative here from, let's see, we have to go from pi over 2 to 0 on this one, because pi over 2 is our starting point. So integral of sine x cosine squared x dx from pi over 2 to 0. So our next task is we actually have to figure out the antiderivative of this integrand. And to do that, this is a good candidate for substitution. I've got a function like cosine and its derivative sine in the same problem. So I'm going to let my u value for this be cosine, because cosine is an inner function whose derivative is somewhere else. So I'm going to say du then equals negative sine of x dx. So then isolating dx, I have du over negative sine of x. All right, let's do some substitution. So I'm going to rewrite this integral. Now I'm just going to do an indefinite integral at this point, and then I'm just going to put it in my evaluation brackets. So I've got, let's see here, this is sine of x times u squared times du over negative sine of x. And I'll deal with these limits of integration later on now. So these signs are going to cancel. I have negative u squared du. Now taking my reverse power rule, this bumps up to a 3. And dividing by 3, I have negative 1/3 u to the third plus c. Now I'm going to substitute back in for x. So this is going to be negative 1/3 cosine cubed of x plus c. And this now is what I'm going to have to plug pi over 2 and 0 into when I actually evaluate my FTC expression up here. So I've got f of 0 equals 0, because that's what y equals when x equals pi over 2, plus I've got now all the stuff I just found in the evaluation box here from pi over 2 to 0. So this is going to be this stuff with 0 plugged in minus this stuff with pi over 2 plugged in. And I mean, this fraction and the cubed cosine kind of look intimidating, but don't be too scared on this one. What is cosine of 0? Well, that's just 1. 1 cubed is 1. So this is negative 1/3 for this first piece here. Over here now, what's cosine of pi over 2? Well, that's 0. So that's actually going to zero out everything over here, and our answer then is just this negative 1/3, choice B.